Okay, so I'm going to put the first equation here in my y equals. And I'm going to make a sketch so I can label all my points, and then that way I don't have to keep using the calculator. So we need minimums, maximums, and then those values will also get me increasing and decreasing. So I'm going to find these 2 points. First one, we'll do the maximum. To go to the left of it. Enter. To go to the right. Enter. Go back towards, oh, let's try that again. I didn't get on the other side. Maximum. Okay, to the left. To the right. I'm going to go back towards it. And this point right here is negative 3.73, 9.80. So I'm going to find a minimum to the left. To the right, enter. And this point, negative 2, or 0.27, 2.87. So the values of any local maximums, well, the maximum point is here, so 9.80. Minimum, the y value, 2.87. And now for increasing and decreasing, pretend like I'm walking on the graph. And as I walk here, I'm increasing. So that is when x is less than negative 3.73. Well, then I'm decreasing in between. So that's when x is less than negative 0.27 and x is greater than negative 3.73. And then we're increasing again as we go on the last piece, and that's when x is greater than negative 0.27. So now I have to put g of x in my calculator. I'm going to graph that one. I'm just going to use the calculator to find the minimums because this is my y-intercept. So that's this point here. So I'm going to find this this minimum here on the left. Left bound, enter, right bound, enter. This point is negative 1.58, I'm on negative 2.25. And now we're going to find the other one. Minimum. Definitely to the left there. Whoa. Uh-oh. Okay, got my calculator back under control. And now I'm going to, hopefully it'll calculate that minimum. Great. 1.58, negative 2.25. Okay, so any local maximums? Is that 4? Now these are absolute minimums because there's nothing below on the graph, but I'm still going to include the negative 2.25 as an answer for the minimum. My graph is increasing. So all of these points are where we're going to change from increasing to decreasing. So if I'm walking here, I'm decreasing. So that's when x is less than negative 1.58. Then I'm increasing between 0 and negative 1.58. And I'm going to decrease again. Positive 1.58 and 0. Then I'm going to increase for the remainder when x is greater than 1.58. Okay, so given the data, I'm going to use the stat function of my calculator. I'm going to enter the t-values into L1 and the height values into L2. I noticed that these are not increasing or decreasing by a consistent value, so it's not linear. If I want to look at the scatter plot, I'll turn plot 1 on. I'm going to go to zoom, stat, number 9. And I see that they're in the pattern probably of a parabola. So using stat again, I'm going to calculate the quadratic regression, which is the line of best fit. So our polynomial is negative 16x squared plus 50x plus 400. So now I'm going to put that equation into y1. And then how high is the ball after 4 seconds? I'm going to I forgot a 0. I'm going to trace over to where x is 4. There we go. Now we can see our line. It goes right through all those data points. I'm going to turn that scatter plot off now. I think that's why I can't trace. There we go. Okay, I think it won't trace over because maybe I can't see it on my graph here, so I'm going to change my window. Oh, that's not going to be enough. I could also use the table. Well, now that's too little. So that works. The height of the ball, f of t, is 344 feet. To use the table, I could go second table, and right here at 4 I see the 344. That would have been faster. When does the ball hit the ground? That is a 0. So I'm just going to modify my window one more time so I can see that better. So the ball hits the ground right here. So I'm going to calculate that with a 0. I have to move to the left of it. I'm going to wait to see when that y is positive. There we go. I'm going to go to the right of it when the y is negative. Go back towards it and guess. So that happens at 6.8 seconds. Okay, so I have to determine what type of polynomial will model the data without a calculator first. So I'm going to find the difference between each of the y values and see when I get a constant, how many levels down. Okay, so I'm going to subtract again. 23 minus 9 is 14. 43 minus 23. 69 minus 43. Okay, we're going to go one more time. 20 minus 14 is 6. 26 minus 20 is 6. So now we're at a constant here. And that was 1, 2. That happens on the third. So I say that the degree is going to be 3. So we're going to do the same thing for this one before I use my calculator. 6 minus 3, 11 minus 6, 18 minus 11, 27 minus 18. One more time. We get a constant of 2 when we subtract all those. So that this is the first level. We're here the second, so it would be an x squared, so a second degree. So for part B, to actually find the model, the equation that models the data, my data is still left in from the problem before, so I'm going to put my cursor on L1 and hit delete. And that took away the column, so actually I have to insert the column back. So instead of delete, we're going to use clear. That's better. So make sure you use clear and not delete so you don't have to put that column back. Oops. Let's try that again. 1, enter, not plus sign. 2, 3, 4. Okay. So I'm going to go into stat, calculate, and because it's to the third, it's going to be cubic. And my, I must have missed a number in my list here. I did. I do not have 5 over an L1. Let's try that again. And we get y, so A is 1, B is 1, C is negative 1, D is 4. Now for the last one, I already put my data into stat, into the L1 and L2. If you want to see how to do that, watch number 77. I'm going to go out, stat, calculate, and we found the degree is 2, so that is a quadratic. I'm going to use number 5, enter. My answer is x squared plus 2x plus 3.